How are you, my friends? This is Calculus 1 solved questions. Let's find the derivative by definition. Question number 1, apply the definition to differentiate x plus 1 over x. So nice question. We can start with the derivative definition. F prime of x will be the limit of this difference quotient, f of x plus h minus f of x divided by h. So I can replace x plus h in the function here. It will be x plus h plus 1 over x plus h minus the function itself. Now just expand here. Take all the brackets out. It will be this one minus x minus 1 over x. Cancel the x here. So we have h over 1, 1 over x plus h minus 1 over x. We have to combine these three fractions. So the LCD will be x plus h times x. So I did it for you in small writing here. You can see that. And then when you simplify, you multiply h plus x minus h. So the x will be canceled. So there is a minus h. Now this one will be fraction multiplied by 1 over h. So it becomes h x plus h x. Just do that, please, simply by algebra. Now, let's continue. From the last slide, we have seen this one for f prime of x. We can take here h as a common factor. So inside, we have x plus h times x minus 1. Cancel the h. We have this function now. Let's find the limit as h goes to 0. So we can replace h by 0. Becomes x squared minus 1 over x squared. Divide each term here by x squared. We get f prime finally 1 minus 1 over x squared. This is the function f, x plus 1 over x. This is the derivative by definition. Let's see another nice example. Given this function f of x, x over x plus 3. First, apply the definition of the derivative to differentiate the given function here, x over x plus 3. B part, find the equation of the tangent line to the function here at x equals 2. So differentiation, the derivative definition, limit of this difference quotient as h goes to 0. Put x plus h in the function x plus h over x plus h plus 3 minus the function itself. We have to add here, too much work here in algebra. You have to add these, subtract these two fractions. So the LCD will be x plus h plus 3 times x plus 3, multiply this by x plus h, and minus x multiplied by all x plus h plus 3. Do that. I did it here for you. You can just read it. You will get the limit of 3h over all this product. You don't have to multiply the denominator, by the way. Just leave it. Don't multiply it. Cancel the h. You get a limit of 3 over 3 plus h plus 3, x plus 3. So when you put h is equal to 0, you get 3 over x plus 3 squared. This is the derivative of the function. Now, x is 2. So this is the point of tangency. X is 2. We replace it in the function. This is f prime. So x1 is 2. Let's find y1. It will be 2 over 5 if you replace it in the function. Now replace 2 in the derivative here, f prime, you get the slope. Slope is f prime at 2. So it will be 3 over 2 plus 3 squared because we have squared here. So 3 over 25. So let's find the equation of the tangent line. Y minus y1 is equal to m times x minus x1. Put the numbers there. Y minus 2 over 5. The slope is 3 over 25, x minus 2. Simplify the equation. Let's apply also the definition of the derivative to differentiate this nice function, f of x 1 over square root of 3 minus x. It will take some time to do that. Let's start by the definition. So we replace x plus h as we did before in the x here. So it will be 1 over square root of 3 minus x plus h inside the radical minus the function itself. Now find here the LCD, this one multiplied by this one, square root of this minus the square root of that. Square root of 3 minus in the bracket x plus h. Now, rationalize the numerator here, see? Rationalize the numerator. So we multiply up and down by the conjugate of this. See, this is a minus, radical minus a radical here, over this is the product from the LCD. Multiply the conjugate of this. So this is the same, but we have plus and plus here. Divided all by h. It's a little complicated. So now on the top here, you multiply difference between two squares. And here you leave it. You will see on the next slide. So this one times this one minus this one times this one. Because we have 1 minus 1 plus. This is what we have from the last slide. So you multiply difference by two squares. This will be 3 minus x minus. In the bracket, we have 3 minus x plus h. Simplify that. 3 minus x minus 3 cancelled. Minus becomes plus x. X will be cancelled. And then only plus h because we have minus is plus h. Divided by this, all divided by h, remember. So we need to simplify more and more on the next slide also. So now we have, this is h over 1. So h over this multiplied by 1 over h. You know, when we divide two fractions, like a over b, c over d. So we leave it a over b times d over c. So the h will be cancelled. So we'll get 1 over all this. See, this is a product. And inside here we have a sum. Let's find now the limit as h goes to 0. So h will be 0 here, h will be 0 here. And then it becomes 1 over 2 square root of 3 minus x all cubed. Because when you put here 0, you add, you get 2. You're adding here 2 times square root of 3 minus x. And here you have square root of 3 minus x. And here you have square root of 3 minus x. Okay, so it will be 1 over, try to simplify it, 2 square root of 3 minus x cubed. Now, for more questions on the derivatives by definition, you can see the Calculus 1 lectures, lecture number 6. And for more questions on Calculus 1 in general, you can see the playlist Calculus 1 solved questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.